Hello everyone, and welcome to this new video, which we will continue parsing our portable executable file using the 010 editor. Now, in the previous video, we talked about the image data directory array, and we saw how we can parse each one of these structures, like the image data directory export, and we found where it's located and how it's located. If you remember, this was 0, so it actually does not exist. And we also looked at the import, the image data directory for the imports, so where the imports are located. And I think if I remember correctly, we did the resource and also we did the debug. So those were the examples that we covered in the previous videos. Now in this video, we will continue to parse the portable executable file, but in this video we are going to focus on the imports. Now this is going to be probably one of the longest videos, just because of there's a lot of calculations that we need to do, and I will be explaining all of these, going through how we get to the, let's say, the imports, how we get to the DLLs that are being imported, and then how from within the DLL, how do we know which functions are going to be imported from the DLL, and whether they are going to be imported by ordinal, or they are going to be imported by name. So we will cover all of this. So it's going to take a little bit of time. So if this video exceeds the 5 to 6 minutes, I apologize for that in advance. So if you remember, last time we did the calculations and we found out how we convert this relative virtual address to a file offset address, and we found out that the address was actually 2E508. And actually, if we go down here, or let's actually just take this, wait a minute, let's take this, or just do Control G and go to 2E508. So if we go to this location, okay, so if we go to this location, actually this is the location where where is it? It's where we have the image import descriptor for the first DLL. And if I click on this, see 2E508, this is the first, the location, the offset to the first DLL being imported by this executable. Again, the offset we found over here in the import, it's an offset to the first DLL that's imported by this executable. Now you might say, how do I find the next DLL? The next DLL, actually, all of these, by the way, as you can see, these are 14 hex. So these are 20 bytes. Okay, these are 20 bytes. Each one of these is 20 bytes. So this one is 20 bytes. If I click on the other one, 20, 20, 20, each one of them, as you can see here, are 20 bytes. And what will happen is, whatever tool, if there's a tool like, let's say, PEBear, which parses these, let's say, DLLs. So what will happen is let's say the code in the back end, what the code will be doing is it will be reading 20 bytes, which is this structure, and then it's going to be analyzing the data which is inside the structure itself. And that's what we are going to be doing, and we will be comparing our results with whatever we found over here. Okay, so first thing, again, each one of these entries, which is the image import descriptor, and as you can see here, we have 0 to 7, because if you remember last time we had 8, or actually we have more than 8. Wait, we have here 26, so we have 27. Means we have 27 DLLs being imported by this executable, and we can double check that quickly. So if we go file header, probably we go to the imports here. If we count them, yeah, not sure if there's a way to, yeah, if you count these, you'll find that they are 27 DLLs. Probably, I'm not sure, I forgot if there's a way. I don't think there is a it's just going to be just parsed until the end. Yeah, I don't remember there's a value that will show this, but I might be wrong. So if I'm just going to go double check quickly. I don't think there is, but just in case I'm wrong, probably my head is not clear, not working correctly. Okay. Anyway, the imports, we have 27 DLLs being imported. So the offset we found over here, again, the offset we found over here is the offset to the first DLL. Okay, now what should we do? So let's open this, and we can see here that we have 4 bytes for like some dummy union name, some name, whatever that is. And then we have, and this is probably where this is coming from. And then we have the timestamp, which is also 4 bytes, but it's set to 0. And the forward chain in this case is also set to 0. We will talk probably about these in some other video. For now, we don't need them. And then we have the name, which is set to 30A8E. Now, again, how do we know this is a relative virtual address? We need to convert it to a file offset address. And if you remember, what we did was we go through each one of the sections, right? So where are the sections? We go through each one of these sections, and we look at the base, the address of. Let me just get. We look at the virtual address. So we look at the virtual address and we check, is this value bigger than the virtual address? And the answer in this case is definitely yes, by the way. But then we also check if this value is bigger than the virtual address plus the virtual address plus the size of raw data. And this address that we have here is actually, yes, bigger. So it's not within this region. So we already did that. I'm going to just skip and go directly to the raw data, or the .r data, sorry. So here we have, again, we have the virtual address, which is 28,000 H, plus we have the size of raw data, which is 9C00H. And if we calculate that, we have 31C00. So 31C00, our 30A8E is actually within this range. So again, I already know that, and it's already telling us over here. Let's convert this value to the file offset address. So what we will be doing here is we'll get the value, which is 26, the pointer to raw data. So we have 26C00H, and then plus we have the relative virtual address, which is 30, right? A8E, also H, and then minus we are gonna subtract from the virtual address, which is 28000H. Okay, so we get this value, 2F68H, and if you look at this one, 2F68E is the address where the relative virtual address to where our what this is called, by the way, this is an address to where we have the import address table. So this is where we have the import address table, okay, or the import lookup table. So we'll look at this. So if we go take this value, and now if we go, and I will also, by the way, add the links to the Microsoft the PE file format, just in case you want to follow that. So now if we go here, okay, now if we go here, you can see that this is where we have what our, and then there are some padding here. This is where we have what our so this is where we have our sorry, from here, yep, all the way to this, and then we have some yeah, this is an address to the name, right? Yep, this is, and this the size is 4 bytes, so relative address. Okay, so this is also where, again, where we have our, just double checking with the so yeah, this is where we have our name of the kernel 32.dll. So that's part one. Now we know the name of the DLL. How do we know where are the functions? And if we go down a little bit, you'll see the address of the first thunk. And this is also an address to, by the way, a table. And this table will depend on the values in it, will depend on whether this is a 64-bit executable or a 32-bit executable. So let's take this value and convert it also. So we get 27520, which is exactly, by the way, what we have here. So if we go now to this location, which is 27520, okay. Now this is if it's a 64-bit executable, then it will be 8 bytes. If it's 32-bit, it will be only 4 bytes. Now, since this is 64, it's going to be these 8 bytes represent this value. Now, what is this actually? The first 4 bytes represent the where the table of the names is located. Where the table of the names is located, excuse me, it's where the table and the hint of the functions is located, and we're going to see how that is parsed. Now the other bits over here, or the other bytes, now if the bit in the bit number 63 is set to 1, then that means we are going to be referencing these functions by ordinal. But if this is set to 0, then it means we are going to be referencing the functions by their name. Now, as you can see here, this is all 0, which means we don't have 1, and it means we are going to be referencing the functions using its name and not the ordinal. So let's go now and find where these functions are located. So we have this. Again, what we need to do is we do 03, 06, and then 8C. Okay, if we hit run, oh sorry, I forgot the H. We hit run. So this is the address, okay, of where the first function is located. Let's go and see. And it's actually the address to, sorry, not the first function. It's actually the address to the hint and the name table. So let's go there now. Let's go there and see how do we parse that one. So we get to the hint and name table. Now, the first 2 bits, sorry, the first 2 bytes, these 2 bytes, these represent the hint value. These represent the hint value. And as we can see here, the hint value for the first function is 02B8. If we look at PEBER, you can see kernel 32. And then if we go to the first function, which is, by the way, if I just continue, let me continue actually, and then go to PEBER. So if I continue, we'll see that we have this all the way until here, right? And then we have some padding, by the way, we have some padding, okay, just to make sure these are padded. And then, so we can see that the first function is get proc address, right? And the hint is 02B8. Now, if we go here, we can see the get proc address. The hint is 2B8, which is exactly what we saw, 2B8, okay? And the first function is what? get proc address. Let's look at the next one. So the system will just continue parsing. Now the next 2 bytes are again the hint. So the hint for the next function is DC, and the next function is create mutex exw, and then we also have some padding. As you can see here, we have some padding, right? We have some padding to make them all like aligned correctly. So we have create mutex. We can see that it's DC, which is exactly what we saw, right? We saw it was DC over here. And then the next one over here, these 2 bytes, which is 0001, which means it's 1, and it's acquire SRW lock shared. Okay, so this is from here all the way, and then we have some padding. Okay, this is acquire SRW lock shared, and if we look at the next function, it's acquire SW shared, and the hint is 1. If we look at the one immediately after it, we can see it's 0114, so it's 114, and the function is delete critical section. Okay, and we have some padding again, delete critical section. And if we look at that here, it's delete critical section, and the hint is 1114, and so on and so forth. By the way, this is how you will be parsing every DLL and all of the functions in it. Now I know this is just one video, but I will do another video to show how to parse another video, and I will also search for a DLL or an executable that will be let's say referencing the functions by ordinal, so that way we'll also see how do we parse those when they are referenced by ordinal. Okay, and then yeah, I'll add maybe 1 or 2 more videos just to make sure you understood that. So again, the first thing we needed was we needed our address to where the import address table is. So the IAT, the import address table, this is where it's located. So once we go there, we can see that the first function, DLL to be imported is the kernel32.dll. From where did we get that? We will now explain it. I'm summarizing things. I'm going to go again mention that, but as you can see, each one of these import descriptors is actually 14 in hex or 20 bytes. So each one of these is actually 20 bytes. The name of the DLL is found over here. So the import image import descriptor dot name will give me where the name is, and then the first thunk will give me where the table to, or the lookup table to the first function and the ordinal of the first function, and then from there you just continue parsing the functions found in that sequence. So that's it for this video. I know it became a long video. I hope this was clear. If not, I will be doing another video to make sure this is very clear to everyone. Thank you and have a good one. Bye-bye.